I'm going to talk to you about visualizing Delphi with Moose. I'm inspired by the humane assessment movement. Tudor Kirba this talked about taking a look at code and understanding code and making decisions about code and what tools we need to make those decisions based on real values, not just ideas. Delphi is an old language. Was very popular when Windows XP first got out in 1995. It is a Pascal-derived language. It's a hybrid OO language, and it was used to build lots of rich client applications on all kinds of Windows platforms. It was widely used before .NET came out, and it's now largely replaced by C# systems and Java systems, and things going to mobile, but there are still lots of old systems where things have to be done. Moose is a re-engineering environment based on Faro. It allows you to visualize code, it allows you to create browsers. It's something we first discovered when we had to do a conversion of a legacy COBOL system to get all the data out of it. And we noticed that we can really fast build tooling to help us with that. We can make visualizations where we can see what's happening with the data. We can take a look at complexities, dependencies, and we can create browsers very fast where we can just look through the code. And on the left you have a system with about 60 browsers. Each browser is about between 10 and 100 lines of code and helps us take a look at some aspect of this COBOL data that we had to analyze. That's why where we found Moose, and because Diego and I, who are working on this, have a Delphi background, we decided that we wanted to apply this to a Delphi tool. So why do we think we need to visualize? We think that we need to provide much denser information than we can by just taking a look at the text screen. We feel a need to look at multiple dimensions at the same time, not just the one dimension that we have from file, unit to class to method. And we need lots of help restructuring and migrating systems. Oh, this is the top of this sheet is not visible. It says provide dense information, and the bottom is visible. Okay. We have been working with larger systems which are several 100,000 lines of code, and if we start working with them, then it's clear that just reading all that code is not going to scale. 100K lines, reading it takes work weeks, and mostly we want to be able to see where we are and find what we should change within days or much faster. And we tend to find larger programs because, well, programs grow as they are used, and Delphi code is 70 years old. Really small programs we no longer find in Delphi because they were already migrated. That's easy. The problems are in the larger programs. Well, so what do we mean when we say we can provide dense information? Well, we have pictures like this where we see 300 files, and we see for each file which other file it is referencing. We try to give some more information in there, and so we give them a color, and we say that the white ones are very small files, and the black ones, or the blacker ones, are the larger files. And we see here that the human brain is very triggered by color, and immediately notices the red blocks, which are the files we had missing from this system. So that's an easy way to show where you find problems. You can also provide an overview over enormous amounts of information. This is 350,000 lines of code. This is the Faro system. And well, you take a look at it, and there are immediately a few things which are interesting. This is a part which seems to have a very regular structure. That's right, that's the refactoring browser nodes part, which is very regular. Other parts are very complex. Hi, something wrong. The highest tower is morph, which is a very complex class. When I look at code, which is large, maybe complex, absolutely thing. So large in terms of lines of code, classes. That still not makes it clear to me if it's a problem for me. If that code never changes or is not often used, then it might not be a problem. If I only have one measurement dimension where I'm looking at this code, then I cannot say if it's a problem. I always have to look at multiple dimensions to find out if this really is a problem. Of course, larger code is more of a problem, but not necessarily a relevant problem for me now. A good example for that in Delphi is virtual trees. Virtual trees is a nice widget component, which is the red part in this object. It can do lots of things. So it's very large. It's 1.4 megabyte of source. It's 38k line. And this is a one-point description of the interface only. So it's complex. And if I want to know if I should be using this component, just knowing that it's large doesn't help me much. I take a look in the news group to see is there many bugs reported on this component, how many users are there for this project, and how many people are maintaining it. Then I get a better idea of if this is a problem. So just looking at that one dimension size doesn't help me. I need to do something else. And what kind of things I need to measure, that depends on the kind of problems I have. This is a Delphi project where we show the forms, which is the visual components. And for that, we decided to have 4 different measurements. We are showing, the edges show the inhabitants. So this form is based on that one, and it's based on that one, all up to the T form. The nesting shows that a form has some methods. The color tells me something about the complexity of those methods, and the height of each inner block tells me how large it is in terms of lines of code. This is a typical Delphi problem. in Delphi, people can write event handlers directly in the forms. So we see here that happened here. And we see that it did not happen with a few of the blocks to the left, which are have little complexity. If the complexity is white or yellow, then it probably means that they only had a guard there saying when the event should be triggered, and then they delegated to the model what should happen when that event was triggered. So if a button was clicked, then there might be a guard telling me that only something should happen if some condition is true, and then that model action was completed. Here it's about 100 lines of code doing something, lots of things, which makes it difficult to change this code.
So the complexity
It's cyclomatic complexity.
Okay.
Yeah.
What is cyclomatic complexity?
Cyclomatic complexity increases with loops, with if-thens.
Okay.
So if you have them there, it will be larger than that. And normally good form code in Delphi is supposed to only test at the beginning if you have some guards which should be true, and then it should just ask another object to do the thing it needs. This is of course only interesting for code where we need to make changes. If it's code which is not going to change and you are just going to use it like it is for the next 20 years, then we are not talking about this problem. But normally we need to adapt to new requirements. We need to be able to move to new platforms, and the code needs to be open to new developers who have to replace people who are retiring. In the case of Delphi, we have older style Delphi, which has to move to modern style Delphi, where there was an old library VCL and it's moving to FireMonkey. The database support changed a few times in the different versions, and that needs different code. The latest versions of Delphi support mobile, and of course we have the things we have everywhere that we move from ANSI to 64 bits and Unicode code.
So do you only analyze the Delphi code, or do you also have the tools to rewrite the code?
We are currently at the point where we have the analysis working and are gradually moving towards refactoring support. Test ID, yeah. So when we find Delphi project, the most important things we have to do with the code themselves, which are independent of the version of the code, is the removal of duplication, moving of event handlers to the domain objects, and making sure that you have a unit test and move to a hexagonal architecture to have better maintainability. For migration support, we took a look at the work that the original authors of refactoring browser did with SmackCC. They wrote a paper where they showed that they could migrate a 1.5 million line of Delphi code project to C# in about 18 months with 4 people, which is about 10 times better than we would expect if you just do a rewrite. So we are looking at copying that, basically. Yeah. Good. Now we can see what we did. Yeah. So we have a Moose model where we can import a file. then we see that it starts parsing. And this is a very small sample for the demo, so we can already do some visualization to see what of this code we already understand. As we are building this Delphi parser to make it possible to import this, we wanted to see which units we could read, what dependencies they had, and what we didn't understand. So here you can see that the green files are well read. The top part is the interface. So in the interface we have the small blocks which tells us how many classes there are. Below that there may be an implementation that was read. And the orange files are the ones which we could not find. Well, that's also shown in the left-hand side. And the red ones are the ones we have parsing errors, which are to be expected because we did not define any of the if-def code which helps us switch between, for instance, Windows and Linux support. So there would be things that would not parse as Delphi code. 2047. So if I take a look at this, then we can see that we have two forms. And we have this same. This is the same picture, but this is a very simple one. So we have only one form depending on inheriting from the form, and it has two event handlers which are simple, which is nice. Unlike in the other project. So, if you now take a look at the source, which is part of this, then you can see that this visualization helps us navigate to the code very fast. We have this yellow method. That's this method, and we can see that the complexity is not very high, but it is still about the maximum what we want. With the red one, we can see that we have here an if statement and a for statement, and that's supposed to be more complexity than we should have in the method. Complexity of the classes. Unit. And here we see dependencies at the unit level, and we see for each unit the size of the classes where the number of methods is in the horizontal direction and the number of lines of code is in the vertical direction. It is very easy to make these kinds of pictures. They are mostly about 100 lines of code. So we often make a lot of them before we find something which helps us show something interesting. So this was what I wanted to show. Oh no, there's one more video. That's the part where this is the part which did work on my machine at home, but not on this laptop. So that's something I will fix. We can not only do two-dimensional pictures, but we can also do the three-dimensional ones. This is the picture we showed before, where we have the three-dimensional view of the whole system, the whole Pyro system, and we can move through that and take a look at it, select elements, and also show something about those elements. And we also just recently, last week, managed to make the same kinds of pictures for a Delphi model. We exported the data and opened this. So this is a picture of the same model. It's a code city model where the gray blocks are the units and these are the classes. And we show here that we have different kinds of measurements. We have done up to 20, and we have selected 3 of them to show in this picture. It's not the right ones to show because you don't see anything interesting from this, but that's mostly because we don't have the right measures for that. Good. Thank you. Any questions?
Is there no inheritance information in this one? In the 3D?
No, I have not put the inheritance information in this one. I could, but no. This is just something which we made work last week. So the important thing was that I was able to create the buildings and make them have nice colors. Yeah.
Oh, that's cool.
Yeah, that's all. Thank you. Any other questions?
Application, how do you visualize that for instance for the library?
Sorry, that is possible.
So imagine you have a library,
Yeah.
no form and other stuff, but just components. How would you look at duplication? How would that be visualized?
Well, the thing we mostly start with visualizing is having the units, the classes and the methods in them, and showing how large they are, and showing what other methods they are calling, how the dependencies are, both at a unit level and at a method level.
Not at the code level. So this group of code lines, because they are
In the same sense, in like finding duplication, or not? Well, for duplication we have different tools who can find duplicates and can find duplicates who are templates or template-like, so have a slight difference or have a few lines between them, and we have tools that, but I have not shown that yet. That's based on views by Vettel, I think.
and they probably find it.
This is, well, the 3D thing is not yet on the Auto Hub, but the parser is part of the Moose project, so you can download a Moose image and run the configuration of the parser of the Delphi, and then you can import Delphi code. Talk to me afterwards, then I'll write it down. Yes?
Have you tried the rules on FreePascal or Lazarus projects?
Not yet.
That you should.
Well, we need to change the parser for that. The language is a bit different, and we noticed that we have now a larger parser than the Java parser for Node. Didn't know that before, but the Delphi language is larger than the Java language.
Are you aware of anybody using moves for Fortran?
Fortran, Marcus?
I don't think so. COBOL, there is a COBOL support for moves, but Fortran, I think maybe something older. But some years ago, someone did something.
Yeah, but we now know how to do that. Now we built some COBOL things and we did the Delphi, so we can also do Fortran. But that's a question of building a parser, making sure that you have the name resolution right, so you can find which method call is calling which.
Okay.
Takes some time, but it's doable and helps a lot with refactoring projects.
How much time did it take you to write a parser for Delphi?
That's about 2 months now. But then you don't have the name resolution yet. And that's also, and yeah, depending on how good it has to be. Good. Thank you very much. The next. Ja.
Die wil ik ook graag. Ik weet niet of jij een...
Er is geen 2.
Oh, dan pak ik maar even Paul.
Yeah, it's called 1024.
This one?
Yeah, plus user.
Okay.
Hopefully. Pretty. What's going on? I gave them my reservation thing, but stupid thing since there's no connection. Is that close to the spoon?
So, time for the next presentation. Wouter Gazendam is going to tell us about another new small talk, gravel.